This video presents an exciting new feature available with the new release of Typhoon HIL Control Center, which allows you to make a custom testing interface for your control system, bringing you one step closer to complete test automation. In this demo, we will use Typhoon HIL 600 and a brand new microgrid interface board with 3 independent TI DSP controllers with grid-connected converter control algorithms that we would like to test. This is the schematic of the power stage our HIL will emulate. Click on the Compile and Open to build the model and download it to the HIL. While we wait, we can take a closer look into the schematic. We have 3 grid-connected inverters, each of them controlled by different TI DSP controller. On the DC side of the inverters, there are 3 batteries. On the right, we have a grid-forming part of the circuit with 2 grid options. One, which is strong and balanced, and the other one, weak and unbalanced, selectable by means of contactor. Model is now compiled. We can load the predefined emulation settings file, including the sources, control feedback signal settings, and scope settings as well. We can now run the simulation. Note that the grid voltages appear instantly. We don't have any current signals yet, as our controllers are still not running. Let's start the controllers and define active power references for each of them. Now, let us move to our new Custom UI panel. We can see that there are 3 different element types available. Those are gauges and displays for signal monitoring, and macro buttons used to set the model into a certain state. Let's start by adding a gauge that will display the grid line RMS voltage. With a double click, Gauge Widget Properties window pops up, where we can change the gauge name, assign the analog signal to monitor, and set the range. To add another one, we can simply copy the existing gauge and change the name and analog signal properties. Let's also add a button that will, for example, unbalance the grid. Simply drag and drop the macro button, customize the size and position, and with the right mouse click, change the name property to Grid Unbalance. Now let's define the action behind the button. Double-click on the macro button opens a script editor window. Commands wizard on the left helps us to generate the Python code our macro button will execute easily. We just find the parameter we would like to change, define the action, which in this case is a different value of a grid voltage, and click on the insert. We see that lines of the code are generated automatically. Let's change the voltages for the remaining sources as well. Save the changes, close the macro code window, switch to the run mode, and execute our new macro to unbalance the grid. It is that easy. We can also duplicate this macro button and modify the code to set the grid back to nominal. Following these example steps, you can build a completely custom testing interface for your control system and open it anytime you want to use this model. With custom macro buttons, you can easily simulate specific grid conditions, converter faults, etc. or generate test sequences like, for example, a frequency sweep, or a low voltage write-through profiles. This example is included in HIL Control Center installation, as well as the Typhoon API documentation, which can help better understand the code structure, as well as guide you to the complete test automation by creating your own test scripts and benches. I hope you will enjoy this exciting new feature brought to you with our new Control Center release. Thank you for watching.